The next lesson with transformations is stretching and compressing. And this is probably the one that's the most different than what you did in grade 11. If you think about grade 11, you had this A value, and we talked about it affecting the width of the parabola. Okay, it's a little bit more than that. Okay, and that's what we're going to talk about today. Stretching and compressing the graphs of functions. We can do vertical or horizontal. The vertical one should be pretty simple because we've seen that A value before with the parabola. Okay, very quickly, the value of A, how does it affect the graph? It's going to be a vertical stretch if A is bigger than 1. It's going to be a vertical compression if A is between 0 and 1, in other words, a fraction or a decimal between 0 and 1. And if A is negative, then there will be a vertical reflection. Okay, so let's try a couple of these. Here we have the original graph, the one that we know so well already. Okay, let's just put a couple points in there. This is x squared. Okay, and if we have a 3 in front. Now last year, what did we say about the 3? A lot of you might have heard us say that looks like it's narrower. You know, the graph's going to end up being more narrow like this. That's not really what's happening. What's happening is A value is 3. This is a vertical stretch. And rather than say vertical stretch, I would even say multiply the y value by 3. Okay, so that's what I would say. I would say multiply y by 3. Okay, that's what I like to when I see that A value. So what is the y value right at the vertex? The y value is 0. If I multiply that by 3, it's still 0. What's the y value right here? The y value is 1. If I multiply that by 3, it turns into this point. And if I take this y value, which is 4, and I multiply it by 3, I end up with the point 2, 12. And now you can see why we say that it looks narrower, but really it's not narrower. What's happened is that it's been stretched. Okay? So that point should be somewhere around here. I don't like that. That's not a very nice graph. Let's try that again. There. Okay, so that's a vertical stretch. On the other hand, here A is a half, so this is going to be a vertical compression. Okay, I'll write that. But again, I don't like that language as much as I like to say multiply y by half. Okay, so if I take this y value and multiply it by a half, it's going to be here. If I take this y value and multiply it by a half, it's going to turn out to be here. Same thing for the other side because it's symmetrical. And you can see that while last year we said that the fraction made it wider, really what is happening is it's compressed. Okay? So the y value ones I think will be pretty obvious to you. I think this makes sense. They're not really complicated. Okay, let's try another one. What is going on here? Here we have A is -2. So you can say that's a vertical stretch by 2 and a vertical reflection, or we can just say multiply the y by -2. Okay, so what's the y value right here? It's 0 multiplied by -2 is still 0. What's the y value right here? It's 1 multiplied by -2, and it's going to be at -2. 0 will stay the same. What's my y value right here? It's -2. If I multiply that by -2, it becomes 4. Okay, y value times 0 times 0. What is it right here? The y value is 2 multiplied by -2, I end up at -4. So I can now draw this in. And it looks something like that. Okay, one more. Here, a is a half, so we're going to multiply all the y values by a half. So we would have something like that. If I multiply this by a half, I get to here. If I multiply this by a half, I still am at 0. And what is the y value right here? It's -3. Multiply it by a half, you get to be right there. Okay? And I guess the trickiest transformation is the horizontal stretch or compression. So let's take a look at that. So now what we're going to do, and this is, we never had this with the parabola in grade 11, we're going to attach something to the x through multiplication. How does that affect the graph? Okay, well the graph will be affected in this way. A point xy, if we put a b value in there, what we're going to do is we're going to divide the x value by b. This is different than the vertical. The vertical will be multiplied by b. Here we're going to divide. And maybe you're saying, well, why are we doing it differently? Why is it like that? Well, I got a couple of ways to answer this for you. The first one is, you know, when we have, let's say we had this. If we had this value, this was an h value of 3, but it looks like we're doing the opposite. Instead of going -3, we're actually adding the 3. So maybe you're saying, well, the behavior when we do something to the x is the opposite. Okay, well that's not a great way of looking at it, but that works. You can always say, well, we're doing the opposite. But really, here's the reason. Okay, if we think back to the parabola, if you have x value, I'm just going to pick 1. If you have an x value of 1, the y is 1. Okay, but now if we look at a new parabola, and this time we're going to put a value attached to the x. Okay, you see there's a 2 there. Okay, and if we want the same value of y, what should we put in for x to get the same value? And you could see that you would put an x value of a half, because if we put a value of a half there, you'd have 2 times a half, which is 1. 1 squared gives you 1. And that's kind of the reason why the b value actually is the opposite. It behaves the opposite. Okay, so maybe you're confused by that. Maybe that doesn't make sense. Let's try a question. Okay, so here's f of x, and we're looking at a b value of a half. And what I want you to remember is that when we have something attached to the x, it acts the opposite. Okay, we're going to do this. We're going to take the x value and divide it by b. Okay, so this is a little bit different. Divide x by a half. Well, if you divide by a half, this is the same as multiply by 2. Okay, so when you see a b value, something attached to the x, it behaves opposite. So when I see a half, this is actually a horizontal stretch. That's weird, because you want to think that's a horizontal compression. It's a horizontal stretch. We're going to multiply the x by 2. So this value would go here. This value is 0. Multiplied by 2, it stays. This value, the x, is 1. If I multiply that by 2, I'm going to end up here. If I multiply this one by 2, I end up here. And if I multiply this one by 2, I end up here. So let's draw that in. Okay, so that's going to take a little bit of getting used to. The x values just don't act quite the same. Okay, let's look at this one. What's the b value? B is 2. This is a horizontal. Horizontal what? Well, I want to say stretch, but it's actually a compression. Okay, what's going to happen? I'm going to multiply my x values by half. Why am I doing that? Well, remember that we're actually going to divide by 2. Dividing by 2 is the same as multiplying by a half. Okay, so my x value is 4 here, now it's 2. X value is 2 here, now it's 1. X value here is 0, it's still 0. X value here is 2, so now it becomes 1. X value here is 3, so if I multiply by a half, it becomes 1.5. Okay. What's going on here? Well, it's a horizontal compression. That's dividing by 2, or I prefer to say multiply x by half. Okay. What is the other one? What is this one? Well, if you divide by a half, that's the same as multiply by 2. So this one is multiply x by 2. This is a great example of how things are kind of backwards, exactly the opposite of what you might expect. Okay, so let's do the first one. If I multiply the x by half, this will go here, 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 and here. So like that, like this. Okay, and if I want to do multiply by 2, this would be like so. That one goes there, there, here, and here. Oops, missed. Missed again. There. All right. So a little tricky. We'll have to get used to that. What we'll do now is we'll go on to combining them, so you're going to have both at the same time. All right. Now, I don't know if you like this. All right. That's what we're actually doing to the point. We have the original point, and we're going to divide by the b values, multiply by the a values. Okay, so what are we doing? This means multiply y by 2. And what does this mean? This means multiply x by negative what? Do we multiply by negative a half? No, we multiply by negative 2, right? Why is it negative 2? Well, you're supposed to take the x and divide by the b value. Okay, if you divide by negative a half, that's multiplying by negative 2. Okay, so let's try that. I'm not sure if we want to do this in one step. You can, but you might want to do them one at a time. Okay, let's see if we can do it in one step. So we'll take this point here. What is this point? This point is negative 2, 0. What are you going to do to the y? You're going to multiply it by 2. What's the y? It's 0. That stays. You're going to multiply the x by negative 2, so it becomes positive 4. Okay, so that's that point. Now we need to figure out what other points we're going to use. Okay, we used this one. We probably should use the y-intercept, but if you know that this is the radical graph, you know these points better. Maybe that's not a good point to use. Okay, so what is this point? This point is negative 1, 1. If I multiply the y by 2, it becomes 2, and if I multiply the x by negative 2, it becomes positive 2. So it's going to become positive 2, 2. All right, and then I'm taking this point, this is 2, 2, and I'm going to multiply the y by 2 and the x by negative 2. Okay, so I'm going to end up with a point way over something like this. This one's going to become negative 4, 4. Okay, just going to draw that a little bit different there, because I can see that one should be right here. All right. I think that I'm going to get you to do this example. Try it for homework, and then we're going to do it together in class. So you're going to remind me. We'll do this one in class. Okay, and there's your homework. All right, we'll leave it there.